Hi, in this video I'm just going to go through some of the common terms that we use in organic chemistry so you can understand what they mean when they come up. So we're going to start with general formula. Now the best way is to take notes as you go through this. If I'm ever going too fast, just pause the video, make sure you get the bits that you can. So general formula. So this is the simplest algebraic expression of the formula. So an example would be an alkane is CnH2n plus 2. So in this, any alkane that we wanted to would follow this rule. So if we take two alkanes to have a look at that, and we'll take, first of all, just methane, the simplest alkane. Let's take butane. If N in this is 1, then hydrogen is 2N, so 2 times 1 plus 2, so 4. And in C4H10 in butane, N is 4, so hydrogen is 2 times 4 plus 2, so we get 10. And so all alkanes follow this general formula of CnH2n plus 2. And we've got alkenes, single alkenes anyway, will follow H2n. So we have C2H4, it's an alkene, C3H6, all alkenes, and they follow that general formula. So next up, we've got structural formula. This shows the arrangement of the atoms in the molecule as we write it out. So it shows for instance, butane up here would be CH3, CH2, CH2, CH3. Showing that we've got 4 carbons bonded in a row, and each carbon has a set number of hydrogens also attached to it. We can go a bit further than structural formula though, and we could look at displayed formula. And displayed formula actually draws out the structure. So this shows the relative positions. So for instance, this is ethanol, and it shows the carbon, and that it's bonded to hydrogens here. This carbon's bonded to 2 hydrogens, but also an oxygen that's then bonded to a hydrogen. And this is the displayed formula. And finally, we've got the skeletal. Now, skeletal are a bit tricky to first get your head around, but then they make life very easy once you have them. So a skeletal formula removes the hydrogen atoms and also represents carbons as just almost lines. So 2 carbons joined together would be represented just by a line. And then if I want to add more carbons to this chain, I could add that, and that is hexane. This has got a carbon here at the end of each line. There's a carbon unless it says it's bonded to something else. And we've got 6 carbons in our chain here, and we just assume that it's then saturated. On this carbon there are 3 hydrogens, on this carbon there'll be 2, 2, 2, 2, and there it'll be 3. And rather than draw them in and take ages drawing them in, we just draw it quickly. We do draw hydrogens in when they're part of a functional group. So for instance, if it was an aldehyde, like this, the N functional group contains an oxygen and a hydrogen, and in that case I do draw the hydrogen in. This is kind of the only case. Now this structure has 1 carbon here, 2 carbons, 3 carbons, and then 4 carbons there. And that 4th carbon, this is bonded, and because the hydrogen's there, there's no carbon here. We're saying this is bonded to a hydrogen, and down here we've got a double bond to an oxygen. They are the 4 kind of key terms that we'll keep on referring back to through this lesson.